Now that you understand work, now you're ready to move on to one of the very important concepts in all of physics, which is power. And power talks about how much energy you're doing per second. And that's really important because if you're doing energy slowly, then it's not actually that useful. You need it all at once a lot of times to do things like light bulbs, etc. So in this case, imagine there's a guy who wants to read his book, but there's been a power outage. But being a clever fellow, he decides, I'll just hook up a light bulb to my treadmill, and I'll have my treadmill provide power. Now he knows about himself that he can do one stride every second and a half, and he knows that his stride length is 1 meter. If the only light bulb he has is a 60-watt light bulb, how much resistance is he going to have to set the treadmill to in order to light the light bulb fully? That means how much force is he going to have to exert on the treadmill as he walks in order to keep the light bulb fully lit. So I'm going to pause. So pause this video and take a second, try to solve it on your own, and then we'll go through it together. Let's look at what we have so far. Well, what do we know? Let's figure out how much work he's doing per stride. So we'll say work per stride. Let's make the force times the distance. What's the force? We don't know what the force is. We do know the distance, however. It's 1 meter. So we're going to do force times meters is the amount of work he's doing. Now, how long does a stride take? It takes him a second and a half to do a stride. And power is work divided by time. So let's do that. Work, force over times meters, divided by 1.5 seconds, is force over 1.5 times meters per second. So now we're getting closer. The final question, how much power is this supposed to be? Well, let's look back at our example. Which of these is in terms of power? Well, the light bulb is. It's a 60-watt light bulb. So looking forward again, we know that power is supposed to be 60 watts. So 60 watts equals 1.5 meters, 1.5 times force, meters per second, to make sure the units come out right. 60 divided by 1.5 comes out to be 40. So we can say 40 watts times seconds per meter. We just inverted that and multiplied, equals force. Watts times second per meter is newtons. So that's 40 newtons. So that's how much resistance he needs to set his treadmill to in order to power this light bulb. It needs to take 40 newtons of force. Now, is that reasonable? How much is 40 newtons of force? Well, that's the same as 4 kilograms times 10 meters per second squared. So he has to do enough force to lift a 4-kilogram weight each time he pushes his leg. It's probably pretty reasonable. He could light up the room and read his book for at least a little bit before he got too tired out. So I hope that you've been able to understand what's going on with this one. We're kind of compiling all of our concepts together here. We started with the idea of energy and then how you calculate work, and now we're bringing it all together in terms of power, which is not just how much work you can do, but how fast you can do it. So if you got this, you're ready to move on to the next unit. And if not, take a second, go back over some of the videos and see if you can't get a better grasp of what's going on with this.